you a couple application problems. The first one is about a water skier that's being pulled up a ramp, and the ramp is 9.5 feet by 2.5 feet. So I'm going to draw a picture. 9.5 feet by 2.5 feet. Okay, so the skier is being pulled up this ramp. If you look in the book, there's a picture of this. You can get a much better picture than what I'm drawing. All right, so they're being pulled off of this ramp. And if we know that they're being pulled at 28 feet per second, that would make their vector this way, the length representing the 28 feet per second. And we want to know how fast is the skier rising. So what we're going to look for is the y component, right? If rising would be the y component. Okay, so to find that, we need this angle theta. So to find the angle theta, we're going to use tangent. Has to equal opposite over adjacent. And theta will have to be the arctangent of that value. Okay, let's type that into the calculator. Okay, so arctan of 2.5 divided by 9.5 is 14.74. Okay, so it's about 14.74 degrees. So to get our y component, we would take the length of our vector, which we said is corresponding to their speed, so 28 multiplied by sine of our angle. Okay, so 28 times sine of 14.74. I'm just going to go ahead and pull that number up from up there. We get 7.13. So this would also be in feet per second. All right, and on the next one, it says that this, with the sun directly overhead, a plane is taking off at an angle of 22 degrees above the horizontal. We want to know how fast is the plane's shadow moving. So the length of our vector that would represent the plane, we would need to know how fast the plane is moving. I must have missed that part. 1 second. We could just make something up, right? So we'll say the plane is taking off at 435 miles per hour. Okay, so for the shadow, we'll think about where the shadow would be. The shadow would be on the ground, right? So we're going to be looking for the x component. So we have our plane. Taking off here, this is 22 degrees. We want the x component for the shadow, so we want to find 435 times cosine of our angle If we take that in, you get 403, approximately 403 miles per hour. Alrighty.